This video will introduce the concept of equilibrium. An object or a system is in equilibrium if its net forces along two perpendicular directions are zero, and the moment about any point is zero. 3 equilibrium conditions. For a two-dimensional system, there are 3 general conditions to satisfy any system which is in equilibrium. First, the sum of all forces along x-axis is zero. Second, the sum of all forces along y-axis is also zero. Third, the sum of all moments about any arbitrarily chosen point is zero. 3 types of supports. Before we go into some simple examples, we need to understand and define 3 types of supports that are commonly used in mechanics. First, we consider a roller support. As the name suggests, this support allows horizontal movement and no vertical movement. It can only provide reaction force in the vertical direction, that is along y-axis. For example, here is a beam, and it is supported by 2 roller supports. First, there is no horizontal load or reaction force, so the sum of horizontal forces is zero. Second, when a 10 Newton vertical load acts on the center of the beam, we assume that the roller supports provide 2 equal vertical reaction forces to balance the applied load, so the sum of y-axis vertical forces is also zero. You can also check that the sum of moments about any point is also zero. We conclude that the beam is in equilibrium. Besides, if the vertical load is pointing upward, the roller supports can provide reaction forces pulling downwards in order to keep the beam in equilibrium. But if a horizontal load or a load with an inclined angle, then the beam cannot be in equilibrium because there are no horizontal reaction force to balance the applied load. Second, consider a pin support. A pin support can provide both vertical and horizontal reaction forces. It does not allow any vertical or horizontal movements. The third one is a fixed support. It provides reaction forces in both directions and a reaction moment. In this example, the beam is not in equilibrium because net moment about the pin support is not zero, and the beam will rotate about it. But when the pin support becomes fixed support, it will provide reaction forces and moment to balance all forces and moments and keep the beam in equilibrium. You will learn more about these 3 types of supports in the lecture. An example of moment equilibrium. Here, let's look into a simple example. There is a ship. Suddenly, the ship is cut into 2 parts. Then, Spider-Man come and hold the ship together and try to keep it in equilibrium. Suppose each side weighs 1000 newtons, and the pulling force to each side are equal. What should be the pulling force from Spider-Man? We can simplify the problem to a system with 2 beams sitting on a pin support. Assume the distance of Spider-Man is 12 meters above the sea, and each side is 5 meters away from him. Then, we can use equilibrium's conditions to find a required pulling force for keeping the ship in equilibrium. Now, let's just look at the right part. We assume the pulling force is P1. When this part is at an equilibrium, we know sum of horizontal forces is zero, sum of vertical forces is also zero, and moment about any point is zero. So, in order to find P1, we can use the third condition and take moment about point A. It implies anti-clockwise moment equal clockwise moment. Then, we have P1 times 12 equal 1000 times 5. That is, P1 is around 416.7 Newton. Assuming that the left part is symmetrical to the right part, the pulling force P2 will be the same as P1. You will learn more about the application of the equilibrium conditions in the remaining parts of the course.